Thank you very much, Mr. Palin. Moving ahead to the next session of the day, Understanding Military Grade Standards Certification Processes for India's Defence Space Sector. The panel discussion will bring together military leaders, certification agencies and industry experts to clarify military grade standards in India's defence and space sectors. Representatives from DGQA, CEMILAC and defence PSUs will outline the qualification processes for defence technologies, including the criteria and testing protocols necessary to meet the military specifications. This session will emphasize the role of certifying agencies ensuring compliance with the joint service specifications and discuss how industry can align products with user requirements. For the same, may I call upon the Chair and the Moderator, Lieutenant General R.S. Reen, former Director, General Quality Assurance, DGQA, and the panelists for the discussion. Mr. Manoj Jain, CMD-BL, Mr. L.C. Mangal, Director, DRDO, Colonel Surender Kumar Rohilla, Standard Development Authority, DPP, Ministry of Defence, Ms. M. Neelavathy, Outstanding Scientist, Deputy Director, Communications, Navigation and Power System Area, and Mr. Vinod S., President, Cebu, Centum. And Ms. G. Manjula from BEL. Over to you, Chair.
Good evening, everybody. Am I audible? At the outset, I first thank SIA-INDIA.
Not on.
That's what I was asking. I think now I'm audible. Good evening, everybody. At the outset, I thank SIA-INDIA for giving this opportunity of not only harnessing the space technology, but also integrating the requirement of standards. Space, as it was rightly said by the previous chair, it's all about the satellite and the ground system. And the speaker just brought out that you have an RF system, you have radar, you have optics, and you have the communication systems. So, space is something which is not different, but it is also integrated as part of all land communication system in different formats. So if you have this in place, then what you need definitely is a standard for design. You need a standard which is for production. You need a standard which is there for qualification of product. That's what was referred as certification. And you also need a standard for product clearance. And in the last, you also need a standard or a working document for sustenance of all this, what you have left in the orbit or somebody in the ground station to maintain it. Now, somewhat down the line, this gets neglected. Adhering to standards and formulation of standards. In my previous assignment as DGQA, we definitely made an effort in putting most of these standards in place, which the panelists will cover. The aim was that for each and every subsystem, whether it's a communication system or a radar system or a ground system or a vehicle system or an optical system, we as a nation need to have a standard in that. And I will just limit myself to space technologies. You are in an outer space, you have put a satellite in place. What may go wrong may not be the hardware, but what may go wrong is something which is a miss in the software part. As somebody said, the resilience, we should have a standby or the recovery mechanism. Therefore, what becomes important is the document which we have prepared for software verification and validation. My panelists from Bell, they were the chairman for that document who have prepared it, but unfortunately, the use is very limited. Gentlemen, at the very outset, why am I using a particular equipment? If I know my requirements, then I should first identify, am I on the right track in identifying those problems or those software bugs or the validation of that process through which I have to go. So kindly follow all those documents which have been listed, and with great help from Directorate of Standardization, gentlemen, most of these documents have been published in year 22, 23, 24. It's not an end, it's an ongoing process, and it may further continue. Few of them, which I will refer to before I go to the panel per se, is the documents which are there on Quality Assurance Framework document, which is there to help you in assessing the total quality framework in which a product works. What we did it, we have aligned it to the international practices and the best global practices available today to you as an industry, as an MOD document, which can be referred and referred with authority. We also have a mechanism for design and valuation. We also have a software document which is aligned to international document IEEE 1020, which I had requested the madam to cover it. Not giving more elaborate, we will move as we move through the session and different speakers speak on it. I will now request the respective speakers to start with. It is Mrs. J.S. Manjula, Additional GM, LCA-EW at Bell, Bangalore? Yes. At Bell, Bangalore. She will give this talk on the defense standards and certifications.
Yeah. I thank SA for giving me opportunity to participate as a panel. Yeah. So our CMD is supposed to come, and because of certain reasons on the thing, I am representing from the Bell. Actually, Bharat Electronics is in all the professional electronics, whatever we take, either communications, missile, radars, electronic warfare, network, anything on this one. So I am belonging to the strategic business unit, electronic warfare and avionics, which presently I am handling the Tejas flight control system and weapon control systems design and manufacturing in the Bharat Electronics. So I will stress upon the aerospace standards, what it is on the requirement on the designs, requirements, as well as on the hardware, as well as on the software on the thing. So generally this IMTR is the guidelines which aerospace, which we are putting from the CEMILAC and DGQA, which is jointly has released the document which governs the entire framework of like a aircraft, airborne stores, or whatever the parts we will use on the aircraft, not only on the thing which we are using even for the maintenance of the aircraft, ground support system, so many, whatever related to the entire aerospace economy, what we can tell, ecosystem, entire thing is governed by the document on the thing. So let us take the realization of the product. The design product which is requires a kind of a phases, which requires a long gestation period on the aerospace. Everybody may be aware because of the reliability requirement which is required for the flight critical system that matters on the highest kind of a factor which needs to be considered for the flight critical systems, I can say on the thing. So when the design qualification, when we take it up, the first is the conceptual design, then it goes with the kind of a pre-development design reviews, then the critical design reviews, then as part of the design review, we can see the test readiness review, which all are mandatory to design on the thing. So this is all will be taken care by the external stakeholder with a kind of a mixed kind of a technology people and different cross-functional teams, which requires for the product realization. So for once we come on to the product, nowadays the requirement is many of the mill-grade components are not available in the market. This is on the one concern. One is considering the cost, one is considering the availability of the type of components. We have to go for the automotive or industrial grade components, which requires a certain additional screening requirements before we take up the qualification on the thing which I wanted to tell. Apart from this, what are the standards which we are generally following? See, this is a standard we will call for the first level on the MIL standard 810 we will do as a product level we will do for the thing which covers so many environmental tests depending on the item location on the flight. Because so many parameters, it will depend on the thing to decide on the test environments, because we are doing on the fighter aircraft, many parameters based on the envelope of the fighter aircraft, the parameters will be decided on the aircraft. Then coming on to the MIL standard 704D, which is related to all power supply test, which is to taken care of the part of the preventive on the aircraft damage. That is on the test which we have to do. The third part which we have to do is a 461 FRG, presently it is G, which is coming on the MIL standard, which covers for the part of EMI, EMC for the entire range, depends on the product on the thing. So this is actually, I can tell, this is a kind of a laborious, detailed test procedures which has been there on the thing, which has to be meticulously followed under this one. Apart from this, what is the next? This is only on the part of the product which we are talking as a part of design qualification. Once the design qualification, see, design qualification to start, not only the thing which we are talking about as a product level. What are the things? Just now we have spoken about FPGAs and other complex memories which we are using. So whenever we use such kind of complex memories and other thing, that the firmware which is sitting in the LRUs or the PCBs which needs to be validated before we are taking into the next level on the thing. That is the standard nowadays, the DO254, which is a very critical standard which goes on the firmware, and that is how generally apply for the that classification is depends on the a flight critical, safety critical, depends on the thing. So that DO254 level A is the highest which we are generally using for the airborne system. That I can say. The second thing is the critical software. Apart from the hardware complex, what is the software which needs to be certified before we are taking to the next level? That is generally DO178C. This is on the software which has to be certified, because most of the critical software which goes on to the aircraft, it has to be certified. The software certification covers so many things. See, certain things is the thing, the way the hardware is designed. Almost equivalent software process are there in the aerospace, I can say on the thing. The starts from the software requirement specification document to the software plan, configuration management, validation, verification, then independent team validation and verification, which they has to do. Then committee has to review with respect to any master plan, any deviations are there. Is it worth in giving the concurrence, or if the deviation, what is the action plan or time plan, or what is the additional safety measure which needs on the thing. So this is, I can say that it is a continuously, this is on the product level to reach this much activities has to be carried out. Once we do this much activity, what is next? Once we will qualify the product, then it comes on the next stage, that is on the integration. Hardware and software has to be integrated, and it has to be simulated with so many test conditions, and it has to be certified for the hardware and software integration. So there comes the application software also, including the application software which we are finally using on the aircraft. That means to say, any product which we are using for the aerospace, it has to be validated thoroughly with all the actual interfaces on the aircraft, and thorough testing has to be carried out. Then it will not stop at this stage. Then the flight trials which comes as a requirement on that. Yeah. Flight trials. Flight trials requirement means any product before you giving into the production into the line, we have to ensure that flight trials are conducted, and then only that product we will get with the satisfactory certification. With all this as a configuration management, we are getting a production clearance. So this is the production clearance, that SOP will be finalized. With that, the stringent manufacturability has to be ensured to meet that the product is replica of the design qualification which we have followed during the design validation on the thing. So this is on the thing. What are the challenges if we take in the aerospace on the thing? See, the way I told the challenges, one is on the thing, because of the stringent qualification process which we have to follow, it takes around 6 to 7 years sometime for the product to realize to come onto the production clearance. So the second thing is on the dependency on the foreign sources on the components, where when the time gestation period is more, sometimes the component may come to the absolute range on the thing.
Correct.
So then where we have to look for the alternate indigenization activities, and we have to do. This is a continuous process which we have taken up at the Bharat Electronics, and alternate components we are going for the ASIC, such kind of critical things, and continuously we are taking on the thing. So this is one thing which I wanted to talk about on the certification process. Of course, the time permits, I can share some more things. Sir is telling that this one, yeah.
We have to respect the audience also.
Yes,
Thank you, madam. I think for the audience, though it went in one flow, but what was important was the time taken in realization of a product and the activities which go beyond that in testing. It's not a simple or an easy process. HALT is one process which she probably wanted to cover and should have covered, is that the time taken for clearance of space-related equipment or mission-oriented equipment is much, much beyond specifications. That's all when your design becomes stable. To give a small incident, last year I got a call from the industry that unfortunately in India we do not have the facilities for testing the printed circuit boards, which is something very common. Even the ISRO has its own standard, the BEL has its own standard. But the person from Saffron who was standing here, and if he wants to import the PCBs from you, the testing has to be done in US. Because as a nation, we did not have a standard for this. So now a standard which is for detailed specification on printed circuit board based on DS class 5999 as JSS 302 revised 24 has been published. This enables you that your PCBs are tested in India. Your PCBs are applicable for all the applications, whether these applications are for satellite or for ground system or those type of printed circuit boards, which as an industry you may export to other countries or for niche products. With this, I move to my next panelist, which is Mr. LC Mangal, Director DRDO.
Good afternoon. I thank the organizers, SIA, for giving me this opportunity for this session. Certification requirements for defense space. It's a very big subject, very complex activity. And before we venture into certification, we need to talk about development, the design aspects, the system configuration requirements.
Correct.
And for that also, unfortunately, considering the challenges which technology is throwing, especially the new technology, which is mainly involving lot of software activities, there is as such no standard for space. In fact, it is not available for ground also. So there is no standard for ground also when we talk about such stringent developmental activities having far-reaching consequences, long-term mission. You want full configurability. You want system which can have very long life. So we have to first talk about the design and development aspects before we call for the standard for certification. Now, what is the nature of developmental activity, design activity that we should choose? I come from a laboratory which works on wireless military communications. And in the past, we have successfully realized software-defined systems, both for satellite communication as well as for military radios. And we have seen the potential of software, how it helps the user to reconfigure it as per his mission requirements. Those mission profiles are addressed in the system through a change of software application, which in that parlance we call it waveform. Now, when we talk about this concept to be utilized for space applications, which if you look at literature for last 15 to 20 years, huge progress has happened in the development of software-defined space payloads. Huge opportunity exists, and with the proliferation of LEO communication satellites, lot of applications which are coming both in commercial sector as well as in military sector, the opportunities are unbound. Huge opportunity, and therefore the country like India, which is having the rich intellectual property in terms of human resource, I think we can leverage that and become the world leader, what our Honorable Prime Minister is visualizing. So in this respect, I think there is a need for talking about certain standard for design and development first, and the related test infrastructure, how to go about testing those things, whether the industry can pitch in, whether government can take certain initiatives on those test aspects, test certification aspects, and then how do we qualify such systems which are having a life extension through software. When I have launched a mission, if I plan that my mission, I want to cover a mission which is going to be 5 years down the line with the same set of space hardware, that means I have to upgrade that space hardware along with some new software. So how do I verify that the software which is going to be launched 5 years from now will work properly on that hardware? It will not have any power supply issue, it will not have any EMI/EMC issue, it will not have any temperature variation issue, it will not have any radiation hardening aspects which are required for space qualification. So these are the challenges which we have to address while working out the design and developmental standard. I think in bits and pieces things are available in the literature, but as a unifying document, there is nothing available. So it is high time that since we are venturing into a very, very new field, I think all stakeholders, the complete country's ecosystem has to deliberate upon it, and I think MOD at government level, especially for defense space sector, must work out some plan of action how to go about it. There is one national standard related effort which we are doing for our military radios on the ground and airborne platforms. Of course, that is not covering the space aspects, but a beginning has been made, and in next 3 years from now, that particular standard will be operational. So we could probably leverage those aspects also. Now, we as a laboratory have ventured into one space-based military satellite IoT network, for which project has started. So that also is giving us a lot of headaches in terms of design aspects for satellite payload, what type of IoT nodes we have to create on the ground, how to connect them, the robust waveforms which are required for link closure, and how to take care of the cyber threats which are coming because of these software aspects. So therefore it is very, very challenging activity. We are addressing them, and in next few years we are also starting work on military satellite payload for actual communication, which is a warfield communication, a very, very protected communication network. There also a lot of challenges are there, and I think we have to utilize whatever is available, our ISRO expertise in terms of standardization on the qualification aspects, and whatever our military people in our missile laboratories has done. I think we have to leverage those practices for coming forward with the proper indigenous standard which can cater to our specific requirements. So with this brief, sir, I can touch upon specific aspects if time permits later.
Okay. Thank you, Mr. Mangla. two important things. One was I should thank DEAL for coming out with a standard which was for the application of SDR. And second, when he said about the testing, now we have placed a software in place which is interactive and which is for the industry to harness it and see where all the labs are available. It's not only the CEMILAC labs or the DGQA labs or the DGQA labs. All the labs which are available in the country are being integrated through this software, where all the tests, all the standards and their requirements, the nature of the test and the cost of the test is also replicated over there, so that there is no delay on part of the industry, in finding where the location is or where the test center is. Second, what's the type of test which is available over there. And third, what is the time frame in which the testing could be done. The testing is not a problem. It's only the failures or the time which it takes for that product or that subsystem or that component to get qualified to be part of that product. Moving ahead, we have Colonel Surender Kumar, Rohilla, Standard Development Authority, DPP, who has been a colleague in the past and will brief you on standard developments.
Thank you, SIA, for this wonderful opportunity to make me a part of this esteemed panel. I am going to take you through the journey of where these standards are available. Most of the time, the biggest complaint which we face is that we do not know where the standards are or whom do we approach for where the standards will be available. So I will just give you the brief of what the ecosystem is and how we can take it further. Now, as we know, India is gaining its own prominent position amongst the various stakeholders in space, and there's no doubt about it. And as we also plant a flag onto the moon, we are finding our rightful recognition in this domain. In the morning, a lot was discussed, and again in the subsequent times will be discussed as to what defense for space and space for defense is all about. This entire slide encompasses where the focus areas are. So now coming to understanding the MIL standards. Gentlemen, what we normally call as MIL standards or MIL grade or MIL specs, they were basically promulgated as the takeoff from normal standards. Now, when we talk of normal standards, I don't say there is any degraded delivery of value in that. But when it comes to the military, what is more important in the morning, what it was told was that there is an intent, there is a will, there is a resolve, and it has a strategic as well as a long-term effect. A political move has ramifications worldwide, and we are seeing currently two wars, ongoing wars, which we do not know when the day comes when it will end. And more nations are getting embroiled in it. And let me tell you, if there was any factor which has played a very important role, it is the sixth dimension which has come into play. Here, precision with accuracy and swiftness matters. You cannot have a delay, and that is why a lot of painstaking effort is taken, as was explained by Bell or Reen sir was saying, and the Director DEAL was also saying that it is a very, very time-consuming process. Now, this is to take you through where the MIL standards are available. Gentlemen, this is a site of the DoD US, which has promulgated these standards. There are various categories which, if you see, become more important because of the anti-satellite features which have also been acquired by various nations to deny this power. I'm sure most of us know what is ongoing here. Can anybody tell me what are the two names of the people who are stuck there? I have some goodies for you. Anybody who can say their names, please. Sunita Williams, who said so? Okay, sir, very good, sir. Anybody else stuck along with her? Sorry, sir. These are two gentlemen. They were supposed to be coming back in Feb. It is again getting delayed. And guess who's come to the rescue? It is SpaceX. Rescue of whom? Of NASA. Now you see why we all are sitting here. General Reen started off with the software error. Gentlemen, somebody in the previous panel had said, it is very difficult to explain code to a person who doesn't understand code. It is behind an abstract layer. There is no physical seeing of a code, how it will act. You cannot assume, you cannot expect 2 plus 2 and 2 into 2 logically will give the same answer. But mathematically, they are two different equations. This is how the categorization is of the incidents. And this unexplainable behavior of the code has also resulted in a lot of accidents. And it has become much more easier with AI. Gentlemen, the present ecosystem in India, we have 5 bodies which make standards, which are for the government sectors. And there are other various agencies which are into non-government standards. Plus, international arrangements are put in place wherein if India doesn't have those standards can be acquired and can be made available. My office is one where we can make accessible to you the foreign standards as well, provided somebody asks what the requirement is. This is the website of BEST, where a lot of standards are already existing. Various councils which are made of experts, they are the ones who work onto these standards. Similarly, most of the nations which have space agencies, be it JAXA, be it ISRO, be it CNSA or Roscosmos, they all have standards which are available on their website, some of them paid and some of them free as well. This is the NASA. There's an entire compendium which is available of what standards NASA follows. These are the various categories, around 544 of them. ISRO earlier used to do it. Now they are having in space to do it. 15 standards already out in the open domain, as also 18 soon to be published. They are already approved. As far as airworthiness is concerned, we have this is the paper which has come out last year only, and it is on the open domain. We have DGQA as well as CEMILAC as the 2 certifying agencies. Now, gentlemen, a lot was talked about cyber security. I'm sure the cyber security specialists understand this 18 gospel mantras. A lot of things is told about AI. Gentlemen, the very basic thing in AI is how good and clean and relevant your data is. Or we go back to the first line of computer science, garbage in and garbage out. So it's not the AI which is responsible. It is the input training sets which we put in. And thereafter corrupt the LLM also. I will end my thing here, sir, because of the paucity of time, sir.
Thank you, Colonel Rohilla. His pitch was high, but the requirement was there to make each one of you understand where you go in for the references to the standards. In addition to that, standards are also available in the references at DGQA website and in Directorate of Standardization, where all the standards which are referred as IS or GSS are all available over there. They are also available at cost. Kindly, those associated in that related industry should have all the references to the type of standards you require. With this, I'll cover a little aspect about COTS equipment, which is also being discussed. Something which is available off the shelf. Do we need to test it? Do we need to develop it? Definitely we may not need to develop it, but we should ask the industry the type of standard which they have utilized, because this misnomer went in for a very long time. They said this is a COTS equipment, it is to be procured off the shelf. Gentlemen, nothing can be prepared, nothing can be procured, nothing can be designed without a standard, and for this we have GSS 082523, which sometimes the suppliers are reluctant to refer to because they had their innovation in GSS Penta 5. Now, when we were formulating this standard, we found that this standard is nowhere inferior to GSS Penta 5. So all that segment of space which goes as part of COTS, kindly refer to this as one of your beginning standards for building that block. With this, I come to my next panelist, Miss N. Neelavathy, Outstanding Scientist, Deputy Director Communication, UR Rao Center for Satellite Center. Madam, please.
Good evening to all. I'm happy to be here as a panel speaker. I'm audible?
Just a bit close.
I'm happy to be here as a panel speaker. I'm audible, sir?
Yeah.
Yes. And coming to the session which is meant for quality and assurance, actually I'm not from that particular area. I'm a designer. So what I am seeing, the difference in maintaining the quality, actually the designer of the subsystem is coming as a separate entity in many of the organizations. Whereas when we speak about quality and ensuring the quality, that is a different department. Both are in the same organization, but they don't gel with each other. That is what I have seen in my experience. So now we are into the era of technology development and innovation, and where innovation has to be more and more, and this kind of quality department and standards, whatever we speak about, it naturally takes a backseat. So what is happening, the people who are interested in innovation and things like that, they are more into a fast mechanism of making their products and then switching over their products and then switching over their total area where they are involved in their design and development, or switching over their jobs. So the quality and assurance itself speaks of more time duration to employ it into the product. In the meantime, the innovation is happening, technology development is happening, and more youngsters, I do not think it is possible for them to get into the kind of quality standards. But speaking in relevance to the session where I am sitting, I would like to say, mainly for the startups and youngsters who are more into the innovation field, you need to take into the quality as a major mantra for your success. But how to do it in a shorter period, at the same time how to become successful in the startups, again you have to depend majorly on the organizations which have been in the industry for more number of years. Otherwise it is not possible, because what is happening here, you take for example a satellite making. What are the standards involved in ISRO to speak here? I can say that we had our own standards like ISRO packs. Later on we moved to ISO 9001, various periods. Then currently we are moving on to, and we are adopting AS 9100D. D is a version from ABCD. And AS 9100, if you take, it speaks about aerospace standards, which is the basic standard is actually ISO 9001. And for all these things, the agency involved is IQAG, that is the International Quality aerospace group it is. And coming to the certification agency and things like that, if we involve, and actually this ISO and other standards are developed by, it is in consultation with FAA, which is the Federation of Aerospace Administration, and in turn it comes under US DOD and NASA. All these standards put together, we take the counsel from them, and then that AS 9100D is followed. And our accreditation and certification agency will be NABCB, that is National Accreditation Board for Certification Boards it is. So speaking about all these standards, if you see, the simple mechanism what we follow is, for the newer generation I would like to say, you try to capture the, suppose you are developing a spacecraft or a launch vehicle or any defense equipment, you try to capture the user requirements, what the user wants. Then translate the user requirements into a document which is called the system requirements document or the functional requirements document. So go through the functional requirements document, sit with the user and see whether the document satisfies all the users' requirements or you have missed out anything. Then later on you make the systems based on the system requirements document. Then your total satellite will split into many subsystems, whether it is a satellite or aircraft or anything for that matter, it splits into smaller subsystems. So for each of the subsystems, you generate the system specifications, that is subsystem specifications. Then each of the specifications, you go into the design board. So design comes into the making of PCB or motor specifications or any mechanical or electrical specifications. So again the design specifications, it has to be handled in a detailed design review, that is called DDRC board, where you cannot involve only the electrical person or the mechanical person if it is an electrical design or mechanical design. You have to involve the related design experts like thermal designers, because you may design a proper circuit which will function properly at ambient temperature and it may fail at a higher temperature due to thermal aspects not taken into account. So you have to think of all the related design experts like mechanical, thermal and harness related, such interface related, all the interface related people have to taken into account for the DDRC. Once DDRC is completed and the circuits are approved in that forum, then it goes to preliminary design review of the subsystems. Then after the approval, it goes into critical design review of the systems. So these are the procedures we follow at ISRO, and it comes under AS 9100D, which we have moved to this year, mainly based on Gaganyaan due to manned mission, and another thing is Bharatiya Antariksh Station. So we have moved to this latest aerospace standards. And here if you see, for some of the examples if you want to see, and further to this prevention of counterfeit parts, if you are using that COTS component and things like that, even for high-rel components, we have seen there may be some few components which is not fitting into the thing. So even if we procure a high-rel component, we go into the screening of the component on sample basis, which is called prevention of counterfeit parts. And then we do the FOD thing also, where foreign object detection is also done. So such things have revealed a lot of problems at the nth moment. And coming to the signal also, we have standards like CCS DBS standards and then DVBS standards. Like that, so many standards are there when you make signaling part for the user to define his baseband requirements. So there are also standards for baseband. And coming to the software, and the software if you take, it is not a single entity. It has to be handled as a holistic approach in combination with the hardware design when it comes to space or define. So what is happening is, once the hardware design is done, then the software gets into the integration of the hardware and software. Here we follow the standard of IEEE 12207, and that particular standard is again changed into ISRO standard, for which for all the Gaganyaan missions and Mars Orbiter mission, Chandrayaan 1 and 2, 3, we have used this IEEE 12207 standard. In turn, it is translated to our ISRO standard, and now it is called IEES, which is ISRO safety standard, software safety standard for the manned mission. So these are the various standards we are using at ISRO. But however, my personal opinion is, sometimes somewhere I feel the standards and qualifications involved here, it is overqualifications. That is my view, because what is happening is too much time is involved in making a product by which the innovation and other things are taking a slightly backseat. And for startup and other people, whether they can do this kind of things in making too many products, scalability and such things for a country like India. See, like if you take Elon Musk, we make 2 products, both the products have to work. So it takes more time. Whereas he makes 100 products, money is there, out of which 90 fails also, 10 will succeed. So where our resources are less, money is less, time is less, we have to compete with others. So high quality standards, if we have to follow, whether it suits our norms and things. And another thing is, there is some bridging has to be done between the innovation and the standards what we follow. That is my view. That's it.
Thank you, madam. Very beautifully brought out. But in the beginning, she said that there is a challenge between the designer and the testing agency. So this is a cartoon between Tom and Jerry, which will continue. And the startups have to follow 2 things. A, what she said, where your design ends and where your testing starts. So put a strong design, your testing will become simpler. And she said one thing was thermal management. Gentlemen, communication equipment and space equipment is all about thermal management. If your thermal management is right, your halt and haste testing is right, nothing will go wrong. But to skip that part of testing, we generally play very close to specifications. When we play very close to specifications, we lower our standards, and an equipment is bound to reach a state of failure when it goes into a critical phase of deployment and the atmosphere or the environmental conditions change. So it is for you and the people from the industry and the designers to decide that standard should not become a limitation for your design, but standard should become a process which is an enabler in your design. With this, I move to my next panelist, which is Mr. Vinod S., President, SEBU Centrum.
Good evening, sir. And it's always at the end of the panel, most of the points have been discussed. But I sit here with some exclusive features. I represent an industry which is both in space and defense. And hence, I'll be able to give industry perspective of what today's talk is about. And today, we are here to talk about the military grade standards and the certification process as the 2 agenda topics for the session. If you look at the Indian space history, it has been about 50-60 years, and out of which about first 30-40 have been only in pure space. Not necessarily everything was defense space. So when we talk about defense space, it's primarily space first. So when we talk about space as space, there have been well-established standards which have been in vogue even in ISRO, in India, as well as in various parts of the globe, be it ESA, NASA, JAXA, MIL standard, ISRO standards. All are very, very well established traditional space. Everything is good. There are rules, regulations, documents. All of that is fine. But staying on the space itself, we also in the last 10 years have seen space moving from traditional era to a new space era, where there have been certain paradigm shifts: speed, cost, quickness, COTS, lateral entry of technologies from different domains such as automotive and telecom. All are also something which is happening in the last 10 years. And the standards for those things, staying again on the space itself, have not yet been well established. If you talk about traditional space, enough literature is available, enough credentials are available. If you talk about new space, each one is having its own recipe, and that happens to be seemingly the IP of the one who is realizing them or one who is delivering the hardware. So there is, with staying on the same space plane, there is some transition happening from traditional space to new space. And if you superimpose the defense onto it, and it becomes a three-dimensional activity which will have to be well addressed. And why defense space needs new standards? Because unlike the traditional space itself per se is niche, harsh, unpardoning, inaccessible for regular maintenance. And the three deadly things, the temperature, vacuum, and radiation, what we discussed, are going to be the key dictators for the standards and establishment and implementation of the standards. And when we transition them into the new space, these things cannot be compromised because, like I said, it's unpardoning, space is unpardoning. But why does defense space needs extra standards? Why not, if we comply to these space standards which we have been complying for the last 50 years, what's so big about? Why do we have to bother and why do we have to talk about the defense space standards today? It is because it is having an additional dimension called the security and compliance to national and international defense protocols. So reliability, anti-tampering, secure communication protocols, battlefield conditions, all will get added to when we talk about space and add the defense space associated with it. So, yeah. So basically, we are moving from one dimension of traditional space to new space to a defense space, and hence it becomes very, very important to not blindly follow the existing standards in each of these domains in isolation, but we have to look at it holistically, and this is the time where we have to look at revising of the standards, keeping in mind removing the rigidity to adding the flexibility, because we're moving from traditional space to new space where we used to do 5 satellites, 10 satellites to hundreds of satellites. So speed, flexibility, all of them have to be brought into the SIG. So there is a good school of thought and a work for all the stakeholders to work on the evolving of these standards. It's not readily available across the globe also. We are no different as far as India is concerned. Whole globe is going through this work in progress kind of a scenario. Now, if you look at the defense space standards, I think in the recent past, a lot of things have been, because a lot of defense satellites are being realized in the country, industries are involved, and hence it is important that the startups, starting from the word go, they are starting into defense satellites, and it becomes very, very important that it is not to be taken so lightly. The importance of standard. Today, so many IDEX challenges and satellite-related systems have been won. Who is auditing? Who is complying? Who is certifying? Who is ensuring that the hardware that is realized is space compliant, can be flown in space? So I think these are all thoughts which we need to give a detailed hearing to and work on it and establish standards in the coming years. And if you look at some work being done, I think already the transitioning from ISRO standards, which are the standard ISRO packs for workmanship, to every particular aspect there are ISRO standards. They are already being laterally shifted to BIS standards, or the standards which are equivalent to what others can refer across the world. So I think the caution for my side is standards are necessary, but the culture of top-down culture of making sure that the standards are a basic elements of a realization of a space system, that culture is the most essential. So standards are necessary but not sufficient. The sufficiency comes from establishing that culture. And also important thing is standards have to go through time evolution, and the rigidity versus flexibility aspect also have to be looked into. So these are my few words for what needs to be a major work in progress in the coming months and years.
Thank you, Mr. Vinod. To sum it up and to say thanks to SAI, I have something as a food for thought. That's for SIA-INDIA. Gentlemen, each one of them referred the standards in isolation. The DEAL is building, the DGQA is building, the private industry is building, the BEL is building, the ISRO is building. Now, each one of the standard has a datum line, and many of them have an interface, because most of the qualification parameters derived from NASA or from 810 or from GSS Penta 5 culminate into one standard. So at a national level, all these available standards should be unified into one structure which can be referred for different application, whether it is space, it's communication, it's radar, it's EW system, it's networking, and for the ground systems. So this has to be taken as a feedback to the MOD, and especially Colonel Rohilla sitting here. We harness them into one, because this is what I have been telling the previous Defense Secretary, is that this has to be built into one national document. So with this, we come to an end. And in the end, I say, for all those who are into production of defense-related equipment, kindly follow the quality management system, which has been integrated as GSS 083324, quality reliability framework procedures for design, development, production and sustenance of land systems as GSS 0829. And the third one is quality validation, system quality assurance, including hardware and software validation, which we all talked about, is GSS 1040. And last, the comprehensive quality assurance guide, which is JSG 0824. Now, it's either ISRO or it is DGQA or any other agencies streamlined into one policy document as a national document, one India, one document. In the end, I thank you all for your patience hearing, and also my co-panelists for being here and enlightening you on this important aspect and subject on standardization. Thank you, Godspeed, and God bless you all. Yeah, if there are any questions, sorry I missed on it. If there are any questions, to best of our ability, we'll take it on and try to satisfy the audience. Thank you.
Thank you, sir. I'm Rajiv Gambhir. I'm DDG at SIA-INDIA. Just wanted to bring to the attention of everyone here. Sir, SIA-INDIA is the vice chair for the government subcommittee for the standards on space and cybersecurity at IEEE, which is the IEEE 3349. We are also the industry voice, and along with InSpace, we are part of the TED 14, taking the industry voice to the TED 14 committee at the BIS. So, being gone through this, we would love to engage with Colonel Rohilla, sir, for the military standards, as well as Mangal, sir, to understand how we could be more productive and do some creative work with all of you. One of the questions that keeps bothering us has been brought out very well, which is about standardization and innovation and the struggle between that. There is one more thing. So in the age today, when it's very difficult to draw silos between civil, commercial, and defense space, having different assets for each one might be, for a nation like us, might be a overkill. Is there a layer of standards that can be developed so that the commercial space assets or the civil space assets can be made applicable for defense purposes as well?
I think the madam will cover it. I'll just cover it in one simple line. Please see the application of the end product. Gentlemen, at the end, whether it is civil or defense, all product into the same requirement at the end. So if the requirement is same, the standards can't be two. Because that's why I referred to what I said was COTS. And COTS is much more stringent than the others is. So my answer is that when you have a standard, so have your compliance to what is best available in the industry. You have anything to add, man?
Just for the info of this August gathering here, very soon there's a Defense Space Application Standardization Subcommittee which is being set up. It is under approval by the RM. The process is already underway. It has got all members from the industry, members from DRDO. The chairman who is going to be heading that is a scientist, F or H level kind of from the DRDO. Plus we are also having the stakeholders like DSA, the Army, Navy, Air Force, as also the various other agencies which are involved, including ISRO, NSIL. We have ISPA and SIA also, SIDM is also there. So these are the agencies which have been proposed. The focus area, as we had shown in one of the condensed slide, that defense for space and space for defense, those are the common focus area which cannot be different from what the civilian requirements are, because now the more and more use of space assets are being done for defense as well. Last but not the least is response time. It is just what Reen sir was also trying to impress upon us, that the turnaround time has to be minimum. If a suggestion or an input is asked for, then if it is delayed at your end, then for processing that at our end, it becomes equally time consuming. So if those things could also be taken care of. Thank you so much.
Yeah.
Specific. However, my question now is to Colonel Rohilla, sir. As of now, under the IDEX initiative, we have a lot of firms which are offering products for trials without any certification. They are also not very sure as to what kind of tests they should undergo, and we are also not very well aware as to where to go. So in the absence, till the time we'd have this one document or this defense application standardization subcommittee which you have mentioned. So in the absence, what should we be guiding them to do as of now? Should they be simply following the standard, the ISRO standards? Because in our case, we are more or less involved in the SATCOM antennas and subsystem. So as long as we don't have these standards, what should be followed in the interims?
So firstly, don't get me wrong in what I said. The standards are available, and standards are there for each product. What I said was that my standard would be similar to what the other standard is. Therefore, we need to change them into a single standard, so there is no misunderstanding or a miscommunication, which has just happened within our talk only. So standards are available for your antennas, for your other systems, whatever the Navy has been following, or your QA agencies have been kindly follow that. This is for a long-term perspective, that rather than referring to a standard developed by a different organization dealing with radar, which is Bell, or by DGQA, which is on part of the land system, can be merged together into one standard. So please don't take this thing back home that we are working on different standards. Gentlemen, we are not working on different standards. We are working on similar standards under different names. So all this has to be brought into and integrated into one simple scope. I hope I have made my answer very clear.
We are not very well aware as to where
so that
we be referring
for
to.
this awareness only the session was there. We have listed the n number of sessions. Kindly go to the websites and find from Directorate of Standardization. If you are located in Delhi, you will have a plethora of standards which are available to you. Find what is relevant for your products. Right. Thank you.
Thank you so much. Indeed, a knowledge sharing session we had. Thank you so much, Chair and the panelists. Can we have a group picture before we proceed for a tea break? Thank you very much. You can join at the Industry Connect with Sri Arun Chaudhary, Director DIITM at the Shamsher Hall, just right after this session at the Shamsher Hall. And we have another very interesting session right after the tea break. So we'll resume here next 15 minutes for the next session to begin.